get you a bowl. Preheat the oven to 350 degrees, please. Well, these cookies look really good.
I know, good job.
They're nicely shaped.
Yeah. But wait a second. We don't have a box to transport these.
What are we gonna do? I don't have any cookie boxes.
Oh, we could use optimization.
Okay, I wonder what the dimensions of this piece of giant cardboard are. Whatever. This is in English.
Let's see. It looks like it is 3 feet by 3 feet.
Ooh, okay.
All right,
let's
you
go.
ready to get started?
On this math problem?
Yeah.
Yeah!
Okay.
Okay, so we can totally make this optimization box while the cookies are cooking. Let me put the timer on. Awesome. Let's start with our 3x3 box. So the height's gonna have to be X, and then the dimensions of our box are 3 and 3. And since the volume of this open top box is gonna be length times width times height, to find out the length and the width, since they're equal because it is a box, we can do 3 minus 2x. So for the volume, we can do 3 minus 2x times 3 minus 2x, and then times our height, which is x. Now we have to factor this equation. So it's going to be 9 minus 6x minus 6x plus 4x squared times x equals volume. And then we're going to have to factor the x in. 9x minus 6x squared minus 6x squared plus 4x cubed is 12x squared plus 4x cubed. So that's our original equation for the volume.
Instead of plugging in all possible values for x, we can derive the original function and find the max and the mins much quicker. So this is our original equation, and the derivative will look like this. So what we're going to do is we're going to graph this equation and then plot it to find where this derivative of the equation intercepts the x-axis, and those two x values should be the minimum and the maximum values for this equation. Here we have two x values, and we can trace to find what the actual value is. So this is one x value, which could possibly be the max or the min, but we will get into that later. So here are two possible x values for our max and our min volume. So what we're going to have to do is we're going to have to do a sign chart to determine which one will give us the biggest volume and which one will give us the smallest volume. So we know that these two are both going to be equal to 0 because we already graphed that right here. cookies are done.
Woohoo! So we know that 0.5 has to be our X value for our box to make our box have a volume of 2, since we used the original volume equation to find the actual volume of the box. So let's go measure our dimensions and make our box. Okay, stop. Are you filming? Okay. Caroline, how did you know which one was the maximum and which one was the minimum?
Because when we used the sign chart, we found that the slope on either side of 0.5 went from positive to 0 and then to negative, making it the max of the function, as opposed to being negative to 0 to positive, which would be the minimum. If I worked at UPS, I'd be fired.
Yay! Okay, and now that we have our box and our cookies, we can bring cookies to calculus for everybody. Yay! Optimization, save the day.
But Lauren, what was our final volume?
Final volume? I don't know. Let's figure it out. Okay, so if volume is equal to length times width times height, and our length was 3 minus 2x, and our width was also 3 minus 2x,
And our height was x.
and our height was x, and x was equal to 0.5, let's plug all that in. Okay, and then so it's gonna be our volume is 2, which is exactly what we got on the sign chart too. Woohoo!
A volume of